In this video, we're going to look at when we use the inverse normal function, which is what we use when we know the probability or the proportion or percentage of values that we're looking for, but we don't know a certain value k where it either starts or ends. What we call this k is a quantile, and what we're going to look at first is the example where we have got the probability that x is less than or equal to k is equal to 0.3. So first of all, let's look at what we have in our situation. We've got a certain variable x, which is all of the data that we've collected. We've seen that the data is normally distributed, which means that we can approximate it with this curve here. We know the mean is 20, so we've drawn that in on our 3 diagrams. And we know that the standard deviation is 3. What we're looking for in this first part is a proportion of 0.3. So what that means is that we're going to have about 30% of all of our data points that are less than a value k. So what we need to do is think about what makes up the normal distribution. We know that 50% of the data is going to be to the left of 20, so 20 or less, and we know that 50% is going to be 20 or more. So if we know that it is less, that our value x is less than k, and that there's 30% of the values sitting there, we're going to have a bit of a guess. It doesn't have to be perfect, but we can pretty well assume that it's going to be somewhere in the vicinity of this. So all of this green shaded area represents values that are less than k. We're trying to find this k value because that's going to tell us what point is at the end of this 30% or 0.3. So things that we need to fill in, we've got 4 pieces of data. To get to that point, we need to go to the menu. We're going to go into the statistics. We're going to hit distribution or dist, which is F5. We're going to hit norm, which is F1, and then we're going to hit InvN, which is inverse normal, and that's F3. So the 4 things that we need, we've got the tail. So the tail represents which side of the graph it is tailing off to. So it's tailing off to the left here. So we're going to write that in. The area is simply referring to the area below the curve, which also means our probability or our decimal value of the percentage. So we've got an area of 0.3. Our standard deviation is 3, as we know at the top, and our mean is 20. So once we put those into our calculator, we're going to find that we have a value of k equal to 18.43. So it's going to show up on your calculator as XINV, and that basically just means our quantile k. In our second example, what you'll notice is that we've still got the same inequality. So we're looking at values of x that are less than k, but this time it is 0.9 as our probability or our proportion. So that means that it's going to be bigger than 50%. It's going to be somewhere around about here potentially. Again, it doesn't really matter. This is just to give you an idea of what you're calculating when you do it. So always try and draw a diagram. So we're looking at all of these values that are shaded here that are in the region which is less than k. So again, we've got our tail off to the left. Our area is going to change to 0.9, so about 90% of all values. Our standard deviation is still 3, and our mean is still 20. If we put this in and we execute, we're going to end up with a k value of 23.84. So again, what this means is that our k that we draw on the graph is representing this point that is either the end of that 30% in the first one, the end of the 90% in this second one. So as you can see, we've got k in the first example, which is 18.43, and that makes sense because we're looking at something that is less than 20. Look at our second diagram, we've got k that is 23.84, which is greater than 20, so again, that makes sense. In our third example, we have got a slightly different inequality. So we have the probability that x is greater than k is equal to 0.7. So when we're looking at values that are greater than k, and we're looking for an area under the curve of 0.7, which means about 70%, we're looking at something like this one here. So remembering that our mean shows us the point where we've got 50% of data on the left and 50% on the right, or 0.5 on the left, 0.5 on the right. So our tail is now trailing off to the right. Our area is 0.7. Our standard deviation is 3, and our mean is still 20. So when we put that into our calculator, what we're going to find is that we have a value of k equal to 18.43. Now, if you look at the green example, you can see that we've got the same k value. This is because in our first example, we're looking for values of x that are less than k, which is 0.3. Now that tells us that 30% of data is below that k. On this example with C, you can see that it is greater than k equal to 0.7. So we've actually just got a combined pair here that would add up to 100 or 1.0. So that is why we're getting the same k value.